Chromecast is a simple way of getting the content you love onto your TV. As soon as we got our hands on one, we got excited about what else it could do. We saw it as a platform for creating interactive stuff for the biggest screen in your house.
So we started playing around and built something that lets people share images from their phones or their tablets to the TV in real time. It's simple and it gets really fun when everyone's doing it together. It's really just an experiment though to show the kinds of things you can do when you combine Chromecast and the web.
And because Photowall is built on the web, it means that everyone can play. You can join in on any smartphone, iOS or Android, or your tablet or laptop. All you need is a modern browser like Chrome.
So now that Chromecast is an open platform, anyone who builds stuff for the web can start building stuff for the TV.
Hello, my name is Kevin Nilsson and I'm a developer advocate at Google. We're here today live from the Google Developer Studio and I want to welcome everyone. We've got some great folks, Norm and Igor on the Hangout with me, and we're going to be talking about the Photowall app that was built for Chromecast as a Chrome experiment. I want to kind of let everybody know that we will have a moderator, and we've got the link on the screen. So if you do have questions for myself or Norm or Igor, either about Chromecast or questions specifically about the Photowall application that was built, feel free to ask those there, and we'll be sure to answer those at the end. I want to start by kind of introducing everyone. And for myself, as I said, I'm a developer advocate here at Google. A lot of the work that I do is to work with partners and help them build amazing apps. And one of the examples of that is the Photowall app. So I actually ran a developer workshop several months ago, and Norm from Hook was there and was able to get his work started on the Photowall app. And why don't I hand it over to you, Norm, and you can introduce yourself.
Hi, I'm Norm. I'm a technical director at Hook. We partnered with Google to create the Photowall.
Cool. Igor? Yeah.
Yeah, sure. I'm Igor. I'm Creative Tech Lead at the Creative Lab in New York. Creative Lab is mostly based in New York. We have a team in San Francisco and London as well. And we partner with all sorts of awesome agencies, production houses, creative types to make experiments and other pieces like this.
Great, great. So one of the things that really excites me recently is the launch of the Google Cast SDK. So that's happened very recently. Prior to that, we were only opening the SDK up to very select partners, but now it's open to everyone in the world. Folks are starting to build some really amazing apps. So it's a really, really exciting time, and we're seeing a lot of great uptake of Chromecast, which is the first cast device. So the Chromecast SDK or the Google Cast SDK is unique because it supports every platform or every major platform. We have an SDK for Android, an SDK for iOS, and a Chrome Sender SDK. So it's a really great thing where iOS is a first-class citizen, Android's a first-class citizen, and the web is a first-class citizen, which I think is something really, really unique, and it really enables people to build great applications. The other thing that's really nice about the SDK is the receiver, which is the code that actually runs in the dongle or runs on your television. That code is written in HTML5. So the code that's running on your television is running inside of an actual Chrome browser. So it's really a Chrome browser running on the Chromecast. And so it's really, really friendly environment for folks, and something that is really easy for folks to work with. So now I want to hand it over to Igor, and maybe you can tell us a little bit about Chrome experiments, because I know the Photowall is just one example. So why don't you tell folks what Chrome experiments are, and we'll talk about Photowall after that.
Yeah, for sure. Yeah, like you say, the Photowall is a Chrome experiment that we've done on Chromecast, and the wider range of Chrome experiments is basically a gallery of creative pieces using Chrome technology, which have been submitted by the creative coding community. They range from simple pieces to demonstrate, for example, WebGL or Canvas or whatever new piece of tech is available within Chrome, all the way up to full-blown applications like the Chrome Racer, which Creative Lab made last year, which uses WebSockets and Chrome on mobile to allow you to create a racing track game with the track that goes all the way across up to 5 different devices. And so, yeah, the Chrome Experiments Gallery was started in, I think, 2009 by Creative Lab, and it's managed by the Data Arts team, and most of the experiments are submitted by just the creative coding community.
Yeah, I think it's really great place for people to go and look, where they can get ideas about some of the great things that can be built using Google technology.
Absolutely, yeah, it's really to showcase that kind of stuff.
Absolutely. So Norm, why don't we jump over to you, and maybe you can tell us a little bit about Photowall, how the app works, what its purpose is, where people can start using the app, and then maybe from there we'll jump into some of the technical discussion.
Sure. Did you want to talk about how we came up with the Photowall?
Yeah, sure. So when we first saw the Chromecast in the lab last year, even slightly before the launch, we were really excited about it, and particularly about the fact that there was going to be the Cast SDK available for it, because we saw that it's really great for streaming video, and hence most of the apps that were being created for it and published were video apps, media consumption. And we just thought it was a really interesting device, and it would be interesting to see if we could come up with ways to use it for interactive applications as well. Often people are in a living room or a larger room kind of experience where they have a large screen and they've all got handheld devices. So if you can connect them up, this is a really nice way for people to interact with each other around this big screen device. And the Photowall was one of the sort of simplest ways we could think of for people to use the connection and basically to sort of demonstrate the connection between the phones and the TV. Just a nice way for people to share the experience at a party or just in the living room. And so we came up with the idea and we partnered with Hook to build it.
Cool.
Yeah.
So Norm, you want to tell us a little bit about what you guys did to build the Photowall application?
Sure. It's really cool because you don't really, when you first think about the Chromecast, you think of it as more of a video device. And when we were approached to kind of take it more social, that was really cool for us. And first thing we did was we just started doing rapid prototypes. There was not much out there on how it actually works on the receiver and what was actually possible and what the environment was like. So we really got familiar with performance, with the DOM and moving things around, whether it was with a tweening engine or CSS, and really just experimented to get a feel for what was possible. And from there we slowly worked out the creative and put it all together, and it kind of all came to life. We used App Engine for the server side, Compute Engine for the mesh network, and it ended up being a pretty large project. We wanted it to live on every device. Anyone could interact with it from anywhere, and it was fun.
Yeah, that sounds really great.
Really interesting. The thing that was really interesting there was just in that process of developing it. It was a very iterative process because there were sort of lots of creative challenges to how we might actually make this work, and also just working together on a new piece of technology where we were learning about it and we were just trying to sort of push it a little bit and see how far it worked. So it was a really interesting, iterative process.
So I'm sure folks online have heard quite a little bit so far, and I'm sure they're going to have more questions as we move forward. So I just want to remind folks that we do have a moderator. If you have questions as we go, feel free to post your questions there, and we'll be answering those again shortly. So Igor, why don't you talk a little bit deeper about that server side? I know Norm had kind of briefly mentioned an overview of some of the technologies. Maybe you can talk about some of the technologies that were used in the cloud and some of the advantages that they have.
Absolutely. So the way that the Chromecast applications run, as you said earlier, is that they're basically just HTML, JavaScript, CSS applications. They need to be hosted somewhere, and we obviously wanted to use Google's cloud platform to demonstrate the capabilities of that. We split the application that serves up the interface both to the Chromecast device and to the mobile devices as well into two logical components. There's the App Engine side, which basically manages the different walls and the matching of new joining users onto existing walls. So when you come to the application, the database stuff is run in App Engine using the App Engine data store, and it makes sure that you're connected up to the right place.
Sure.
And we have the separate part of the application which is running on Compute Engine, which gives us a load of live WebSocket servers, which is how the devices communicate with the Chromecast. Normally, in a Chromecast application, you tend to just do communications between devices that are all on the same Wi-Fi. But we thought if this application were to be used at a party or an event, we wouldn't want people having to remember or learn complicated Wi-Fi passwords or anything. So we wanted them to be able to just use their own 3G or 4G connection on their phone. So we set up this mesh network that allows direct communications between the handset where people are submitting their photos and the Chromecast where they're actually getting displayed. And so that division between App Engine and Compute Engine was really quite natural because it allows us to scale the size of the Compute Engine resources according to the amount of traffic that we've got. So the App Engine system knows how many users we've got and can talk to the WebSocket service to find out what kind of load they're under and decide whether it needs to spin up more instances of the WebSocket servers. So it does all that using the Compute Engine API. So I mean, this has been a really good experiment for a range of Google technologies, really. Pretty much automatically scaling the server system depending on who's coming in, and using the really powerful resources of the App Engine backend to not have to worry about scaling data store, which can often be, a real pain in a large application.
Yeah, that's awesome. That's awesome. So Norm, maybe you can talk a little bit about Chromecast and the development. What development is like there? What are some of the things that you liked about it? What are maybe some of the things you didn't like about it? Because I know Igor has talked quite a bit about the cloud and the back end, but a lot of what this Chrome experiment was about was getting out there with Chromecast and showing what can be done with Chromecast.
One of the cool things is the fact that it is just Chrome. So if you're any web developer, you're going to feel right at home. It's really simple to build an app. You get your app ID and you have a place where you store your app online, and from there it's just upload and testing, and it makes it really simple. You actually have your Chrome developer tools that you can access on the receiver, so you can inspect the DOM on the receiver, you can see your console, you can set breakpoints, and you can do all the things you would normally do right on the Chrome browser on your computer. And for us, one of the great things is sometimes we wouldn't even develop right on the Chromecast. We develop right in Chrome on our desktop, and then when we push, it'd work exactly like it did. And it was a cool process. We kind of there were certain performance hurdles that we had to deal with. There are some differences with the efficiencies. We had to be very considerate of memory, making sure that we didn't hold too many images in memory. We preloaded all of our images, and one of the things we experienced was when adding those to the DOM, there would be a flicker of when that image loaded on, and swapping background you'd see a flicker despite it being preloaded. So one of the things that we did to get around that, which is a pretty cool workaround, was we used Canvas, and we didn't actually see any performance problems making that switch. We instead of using actual image tags, we used a Canvas tag. So we preload our image, draw it to the canvas, and then add it to the DOM just like it were in a normal image element. And we had we didn't have to worry about that flicker or that load. And overall, it's really easy platform to get into and develop on.
Great.
Also, that just sort of points to one thing that we should mention, is just that we thought about doing this because we wanted to have an experience on the Chromecast that wasn't just about streaming video, and obviously that we made a rod for our back somewhat, because the Chromecast is really heavily optimized towards rendering full screen video, and it does an amazing job of that, but it just meant that there were some extra challenges in getting the performance, and so it was really having to do neat tricks like what Norm just described.
Yeah, we kind of tested using tweening engines. We kind of tested doing like all canvas, the entire screen. We tested CSS3 animations, and we found that the CSS3 animations actually did perform really well. You had to be careful about how many things you were animating at once, but overall you could get some really nice smooth transitions, which is how we do the image sliding. Those are all CSS3 transitions, and great platform. It's just like building on the desktop.
Yeah. So one of the things that you had kind of highlighted earlier was talking about being able to use the Chrome dev tools to debug your cast receiver application, and I'll talk a little bit about that so folks kind of understand what's possible. Is the code that's actually running on the television or in the Chrome receiver, you're able to take your laptop or your development environment, take Chrome, go to port 9222, and what happens is it sets up a remote debugging session where you're able to set breakpoints on your laptop against the code that's actually running inside of the Chromecast. And I think it's really, really nice, because for web developers, they're very familiar with that, and it's really, it's a very comfortable environment. They can use breakpoints, use the debugger, use the console. They can modify the DOM. It's a really, really powerful tool in making it available to Google Cast developers. So I'm sure, Norm, you and Igor both learned quite a bit in developing this application. And I know, Norm, you'd talked about some tips about using Canvas. Do you guys have any other tips that you'd like to share with developers? Something that that may help them as they're jumping into the Google Cast SDK.
Sure. I mean, the things that I dealt with on this application were mostly on the server side of things, so I'll leave Norm to talk about the most learnings for the Cast SDK. But just for my part, it wasn't really a huge, it wasn't a new learning, but it really reinforced something for me, which is that when you are building an application that is going to be developed for the cloud, you are effectively using components, or a collection of components that are expected to just fail. This is what the whole cloud computing kind of revolution has been based around, and on Google and others realizing that you can use a lot of effectively commodity components to be able to build a much bigger system if you allow for things to just fail. So just always remember that you cannot have any single points of failure in your application. You need to try and make sure that you don't store state in your application servers. You share nothing across those, so that if a virtual machine just dies, you can just reboot it and it will take over. And if you are storing state, so for example in our case with the walls and the photos that are being kept on them, use a central system like App Engine, the data store and the blob store, which were enormously powerful and really useful for us. In terms of the client side, like I say, I'll hand over to Norm for that.
Sure. One of the big things, I got to experience all the SDKs, the Chrome SDK, the receiver SDK, the Android SDK, the iOS SDK, and they're great platforms. I guess the one thing I would recommend is kind of starting with your receiver first, and kind of really get involved with that from the beginning and figure out how you want to have your TV experience, and just really get involved with what's possible. It, we pretty much achieved everything we wanted to with the right prototyping and experimentation, and just really take the time to learn the device and what it can do. And I mean, that's the biggest thing.
Yeah, I think that's a great recommendation for folks, because it is HTML5. You can run that standalone, run it in your browser, and then slowly start integrating the cast functionality. It's a great way to transition your development. So one thing I want to kind of point out to folks is talking about getting started. So if you are looking at, you're inspired now about writing a Google Cast application, if you want to get started, there's a lot of great documentation online, but then there's also some great examples on GitHub, and I actually wrote some of them. But maybe Norm, you can talk about any experience you had with the documentation or the samples.
Oh, I probably know them as well as you do. No, I went through every single one. They were actually probably one of the most helpful things. The documentation can only take you so far. Having solid code samples really helps. You can have it as a starting point. You have some basic Hello World examples up there, which were great. And then you even had a tic-tac-toe game, which I referenced a few times, to see how you guys did that, your communication, and just they were really helpful. I gotta say, even the Cast companion library for Android is a great starting point if you're going to use the Android SDK.
Yeah, definitely the Cast companion library, or CCL, we often refer to it as, is really great thing that really simplifies a lot of the Cast development, and hopefully for most folks, they can leverage that, plug that into their application, and get up and running really, really fast. And I know a lot of the partners, a lot of the apps out there are using it and really, really happy. So can't say enough good things about it. So one thing, I want to jump into the Google moderator questions that we have, because we're running short on time. But I do want to remind folks that they can look at the Google developer blog if they happen to have, want to learn more about the Photowall app, or want to learn more about what was done. There's definitely a great post there that goes a little bit deeper detail in some areas than what we've done. But with that, I want to jump over to the moderator, and we've got some great questions up here. It's not too late. If you do have more questions, feel free to jump over there and add more questions. And so I'll jump into the first question. The first question I see is what JavaScript frameworks or library, if any, were used to develop the Photowall receiver application?
We built it like a normal web app. We used Backbone, the JavaScript library that handles kind of application architecture. We find that's an easy, starting point for any web app. We actually did our CSS using Sass, which is a CSS preprocessor, which is really nice to use. It can, for cross-browser development, can really speed things up, but also just a ton of quick things to make CSS development easier. And we use jQuery, obviously, as part of Backbone. But, we used a ton of frameworks. On the front end, we used Tween Max, the GreenSock library, Tween Lite. I think I used jQuery Transit to help with some of the CSS3 animations on the receiver, which was nice.
We also used the Tailbone framework, which was how we did the mesh networking. It was written by the data arts team over in San Francisco for a previous Creative Lab project, and we just thought it would be a good fit for the kind of communications that we wanted to be able to do. So we took that, we made some modifications for ourselves so that we could run the WebSockets over SSL to make sure that everybody's information was staying super secure. And that's available on GitHub as well, and the data arts team.
Great. So there's kind of a follow-up question that says, how would you rate developing for this platform versus your past experiences? But definitely I can hear you guys talk about using things like Backbone and jQuery, and it sounds it sounds very familiar to developers. But maybe you want to highlight any surprises you had there?
I mean, it's a Chrome engine that runs on this dongle. It's pretty amazing that you've got such a small and good value dongle that does what it does. And so, like Norm's been saying, and like you said just now, it really does translate very, very well. That's one of the things that I find so exciting about the Chromecast, is that it's a really quite well featured creative coding environment that you can plug into your TV and don't have to worry about having a multi-$1,000 graphics interface. You're not obviously going to get the performance that you'll get from something like that, and you're not going to get the performance that you're going to get out of using a C++ graphics framework.
Yeah, and that sort of segues really well into our next question, which is what sort of impact did the performance of the Chromecast device have on the way you design the application? So maybe Norm, you can talk a little bit about that?
Yeah, that was the biggest thing. There wasn't really, it's not like you're learning an entirely new platform when you jump into the Chromecast. It's really quick to jump into. The more things you're learning is about what it can do, what it's capable of, just like any device, really. Back in the start of Android, you had to learn about the platform from those aspects. And, it just makes it, it's really simple. Any web developer can pick it up, and, anybody that has a website can integrate with it. And,
so
a
one
short
of the
development cycle, and it just, you don't have to build an entirely new application to integrate with it. You're just building the receiver, and the actual integration from the sender side is extremely simple.
Sure, of course. Yeah, so one of the things that I do want to highlight is the device is highly optimized for video, kind of like Igor had mentioned earlier. But when you are working with regular DOM elements, you definitely have limitations. So one of the things I'd recommend is make sure that you only have one moving element on the screen at a time. That's one thing I'd talk about. Another thing I would talk about would be, we found with our experience that fading things in and out was a whole lot better than sliding things side to side. So when you're trying to do transitions, from one photo to another, or whatever it is that you're trying to do, definitely movements, need to be slow. And and for myself, I felt like I had a lot better luck fading things in and out. So that's just a tip that I found.
Yeah, we definitely spent a while kind of tweaking our animations to get it, just right. Ours is constantly moving. We're moving things pretty much nonstop, and it's a matter of when you're moving things. We're not moving a lot at once. We're definitely just kind of cycling one after the other. You could still create really cool effects and just manage the performance.
Yep. Right. Yeah, I think what's possibly kind of key to point out is that developers shouldn't expect to just take their existing app and throw it up on the Chromecast. They are going to have to do a little bit, and really kind of optimize their app for Chromecast. But I think that's a lot of the beauty, is building something that's going to work really well there. So the next question that we have is asking if we can speak about how the app was hosted. And I know, Igor, you talked a little bit about that previously. Maybe you can just give us a quick note on how that was done?
Yeah, well, I mean, as I mentioned earlier, it was exclusively using App Engine and Compute Engine. The App Engine app uses the Compute Engine provisioning API to specify how many instances of the Compute Engine we have. Each one uses a predefined image, which boots up a load of software that has been designed to be able to serve up the WebSockets using a Node.js server. The management application that runs the walls, etc., on App Engine is all written in Python, and that's about the size of it, I think. I mean, it's fairly. If you get into the guts of the tailbone stuff, you can see how that all hangs together. But the App Engine framework really makes building data-driven dynamic applications quite straightforward.
Yeah, and there was one other big component of this was the video rendering. We use Compute Engine for that. We're running, basically it's all Python driven. We're using FFmpeg, which is open source. We're using a sound library called Vox, I believe it is, VOX.
Sox.
Sox? Yeah, that's it.
Yeah.
I'm sorry.
That's right.
And then the Python image library as well. And we kind of use that to stitch all the images together. And it kind of runs basically a queue of this video service, and it'll take as many as it gets sent and uploads it, integrates with YouTube, and uploads your video straight to YouTube.
Yeah, that's great. And that's another one that interacts between Compute Engine and App Engine, because App Engine manages the queue of when a wall has been closed. When a wall gets closed or it times out, then the Compute Engine notifies App Engine, and the Compute Engine instances that are doing the video processing talk back to App Engine to work out, okay, which pictures should I be using, how long does it take, let's render them out into the image and then send that out. So yeah.
Yep, and then we notify App Engine when we're done, and it sends a confirmation email. And
exactly.
Yeah. So we're about out of time, but what I do want to do is just run through the last set of questions really quickly. The next question we had was talking about how we generate the video, which I think Norm just kind of talked about a little bit. The next question would be, can you describe your experiences with testing and deploying the Photowall app? And I think we've covered that pretty well already as well. The next question is, are there code examples for Android and iOS? And is there any other great resources that you can look for to get started? And we've talked about github.com/GoogleCast is a great place. And then also on developer.google.com, you can look at the cast entry there. And then the last question was talking about how do you deal with simultaneous App Store and Play Store releases, and how long did it take for the iOS to get approved?
Oh yeah, okay. So obviously there's a kind of separate process for each of those. Google and the Play Store has their own system that we have to navigate and manage, which was, as you know, we were inside Google, that was manageable. But the iOS store approval, we just submitted the app just like any other developer would do, and waited for a response. We had one rejection, which I think was, I can't remember the specifics, but it was quite sort of nitty gritty of the iOS API, and it was, just I think really normal part of the process. They gave us some feedback. We changed that so that we could address feedback, and then it got approved a little while later. I think it was about a month in total for the iOS process. But then, with both of them, you can have them approved and ready to go. So then it's really down to the individual to work out how they're going to release them.
Great. So with that, I want to thank everybody for joining us on the live feed today from the Google Developer Studio. Again, my name is Kevin Nilsson. I'm here with Norm and Igor, and it's been really great telling everybody about the Photowall application. And please tune in next time for more events. Thanks a lot, everybody.
Thanks for having us.
Thanks a lot, guys. Thanks for